now we're going to start a new topic called electrolysis.
Dr. Bourne, all sounds very exciting now. What exactly does electrolysis mean?
Okay, so if you split the word up, you've got electro, which refers to electricity, and lysis, which means splitting up. So you've got a substance which is being split up by electricity. Electrolysis.
Fantastic, right. Now, what kind of compounds can be electrolyzed?
Ionic compounds.
And is there any particular reason why these compounds can be electrolyzed?
Because they have charged particles called ions within them.
Now do the ions need to be mobile, or can they be fixed? For example, an ionic solid, does that undergo electrolysis?
No, it doesn't, because if you remember your definition of electric current, it's a flow of charge. So the charged particles have to be able to move or flow. If you've got a solid ionic substance, the ions cannot move, so there is no electrolysis.
Oh, that's because they're fixed in place.
They're fixed in place.
So therefore, ionic compounds such as molten ionic compounds or ionic compounds in solution will undergo electrolysis. Is that correct?
That's correct. And we've got some little arrows here for you to put those in. Molten or in solution.
Or in solution.
Okay.
Now, when you write a chemical equation in solution, it generally is represented by which symbols?
AQ.
AQ.
And this is a typical electrolysis circuit. So we've got the battery here. We've got wires connecting to the graphite electrodes.
Right, so that's a battery, so that would be the positive and that's your negative part of the terminal.
Absolutely.
So these will be your graphite electrodes. Why do we use graphite, Dr. Bourne?
Graphite, if you remember, does conduct electricity and it's relatively inert. So it's very useful as an electrode for electrolysis.
But why does it conduct electricity, graphite?
Even though it's a covalent substance, it does have a free-moving electron which is able to conduct the electricity.
So it contains mobile electrons which can transfer the charge. That's fabulous. And this is wire.
So what do you think conducts the electricity in the wires?
Metals, because we all know that metals have delocalized electrons. Now this electrolyte, so the electrolyte must be ionic compound, which is either molten, which is the liquid form, or in solution, which is the aqueous form.
Right.
So if we, in this electrolyte, we'll have positive and we'll have negative ions. So for example, it could be something like chloride, Cl negative, Na plus, which is a positive ion. So if that's the graphite electrode, it's connected to the positive.
That's positive.
That would be positive, and that would be negative. Is that correct, Dr. Bourne?
Absolutely. So, Miss McLaren, what do you think the ions in here, in the electrolyte, they're mixed positive and negative, which way are they going to move?
Well, I think the negative ones are going to be attracted to the positive electrode.
Because opposites attract.
Opposites do
as we know.
Yes. And the positive ions are going to be attracted to the negative electrode. Now, Dr. Bourne, do they have any special names?
Indeed they do. Now, the anode is the positive electrode. So it's positive anode, negative cathode, and people sometimes remember that by the mnemonic P-A-N-C, PANC. Positive anode, negative cathode. So this is the positive anode and this is the negative cathode.
You learn something new every day, don't you? So these ions which are attracted to the cathode and anode, they have special names. Dr. Bourne, can you tell me this?
So the cation is attracted to the cathode. The cathode is negative, opposites attract. The cation is the positive ion.
Right, so that's got to be a positive ion.
Yes.
I think I prepared a board earlier.
Have you? With positive ions on. Lovely.
here's a list of cations, and they're all going to be attracted to that cathode. It's very attractive.
And the anode, that's the positive electrode, will attract the negative ions. So the negative ions are the anions. So the anions go to the anode.
So the negative ions, so opposite charges attract.
Yes.
And again, I prepared even another board which actually illustrates some of the anions we're going to be dealing with in the next vlog.
So they've all got a negative charge, you can see here. So they're negative ions, anions.
Well, I think we've actually been quite electric in this vlog. What do you think?
Oh, absolutely sparking.
Perfect.
Okay.